So we went through these ones where it was like the fourth term, the third term, the middle term, last day. Yes? If it asks you for the fourth term, what's that telling you? What's that giving you? Yeah. K. K equals 3, because K is always one less than the term. So if it gives you the term number, it's giving you K. This is true. If we know n, which is the exponent on the binomial meaning 2 terms, if we know our n is 6, how many terms do we have in that expansion? 7, because it's always one more, because we start at K equals 0 and we go to K equals n, so we're always going to get one more term. We agree? So those were all the ones we dealt with where they kind of gave us the term. Now what they're going to do is they're going to give us some information. We always will know the binomial. So we'll always know x, we'll always know y, we'll always know n. Sometimes our y or our x is a variable we have to solve for, but we'll always know those, correct? It's the k that changes. We agree? So what they're going to do today is what I'm going to do, because I made the notes. What I'm going to do today is I'm going to give you questions where I don't say term 3 or term 5 or middle term. I give you some other piece of information to find k. Okay? Okay. So this one here, the term with the y5 in 5 minus 2y to the 8 is. Okay? So let's fill in what we do know so we're not overwhelmed. If we fill in what we do know, this question's really, really easy. Okay, so let's try that out. We do know that we should rewrite this as 5 plus negative 2y to the 8. We know that we should do that. Why do we have to do that? Why do we need a plus sign? Anyone know? Yeah. Yes. You are correct. In order to use this formula here, it says on the formula sheet that in the expansion of x plus y to the n. So in order to use this formula, I have to have a plus sign in between. So if I don't have a plus sign in between, I cannot use this formula, which means I'm stuck. Okay, so I have to get a plus sign in between. So what do we have? We have x. So x equals 5. I'm going to state my knowns. We have y. Y equals negative 2y. And we have n, which equals 8. And we don't have k. And they didn't say second term, they didn't say third term, but we can find k because they gave us a piece of information. They said the term was y5, okay? So if I don't know k, I instantly fill everything else in and put boxes where k would be, because then it'll be easy to find it. So let's try that out. So the formula is nck, x to the n minus k, y to the k, and it's given to you, correct? So you don't need to memorize it. So let's fill in what we know. It's 8c box, because that box is the k value and I don't know what it is. I'm going to fill that box in soon. And then I go x, which is 5, to the 8 minus box. And then I have y, which is negative 2y box. And I need to know what the heck to fill in for that box so that I get a term with y to the 5 in it. What do you think we should fill into that box? I need a term with y to the 5. 5. Why? Exactly. And the other term doesn't have any y's. We agree? So this didn't have any y's. It's the only thing with y's. It's y to the 1. I need to raise y to the 1 to the 5 in order to get y to the 5. We agree? What's great about this is I've just found every box. Each of these boxes are always the same. So once you find one box, you have all the boxes. I fill 5s into everything. And make sure you're writing notes, because when you ask me a question and say, where was this? I'll say, look in your notes. If you don't have any, you have nothing to look at. So what's 8c5? Anyone get that? Yay, nay? 56. And then we have 5 to the what? What's the exponent going to be? 8 minus 5, which is a 3. 5 to the 3 is 125. And then we have negative 2 to the 5. And remember when we put it in our calculator, if we want to put it in our calculator, we have to put the negative 2 in brackets. So negative 2 to the 5 is negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which is negative 32. Y to the 5. If you're the person who's still forgetting to put that 5 to the 2 in front, leave yourself a note, right? A lot of people will put it to the Y, but they'll forget to put it to the negative 2. Remember I told you they're going to have that error there? So we don't want to make that error because we'll think we're right and we're not. What's our last step here? Multiply the 56 times the 125 times the negative 32. Negative 224,000. Y to the 5. Now they could ask me two separate questions on here. The term with y to the 5 in 5 minus 2y to the 8 is that term. If they ask for the term number, what term number contains y to the 5? What variable helps us get our term number? Yeah. Yes, y. K is one less than the term. So we know that k equals 5 in this case. So if k equals 5, remember, if you can't remember if it's less or more, think about it. Okay, term 1, k has to equal 0. So k is 1 less than the term, correct? So if I have k equals 5, then this is actually term 6. We are of the times my daughter does not know that that's a number sign. She's like, Mom, it's term #6. I'm like, oh my gosh. Oh my gosh. She signed her name on her, like, she was player of the game for hockey. And so she signed her name on this. They have a Wonder Woman's cape, is what they get if they win. And so she signed her name. She's like, Mom, I signed Isla #2. I'm like, number 2, child. That's a number sign. In this case, it is not #2. But yes, she's 8. So there's that. All right. So this one, it says the constant term. What the heck is the constant term? It's actually labeled quite nicely. Sometimes they like name stuff like a 0, which has a 0. Okay, root. Well, what the heck's a root? But a constant term is actually labeled correctly. It's a really good labeling for what it is. Yeah. No, not exactly. Constant. Something remains constant. What happens to it? There's no variable. The one that's constant remains the same. It doesn't change. So if I had this, and I'll erase this after, but say I had y equals 3x squared plus 6x plus 1. We're used to y equals, correct? But in grade 10, we were taught there's something called functions. So we had f of x equals. We agree? And we learned that, hey, I can fill any x in for here, and I'm going to get an answer, which is going to be my y, technically. We agree? So if I fill in a 1, I get 3 times 1 squared plus 6 times 1. Great. If I fill in a 9, it's going to change this. It'll be 3 times 9 squared plus 6 times 9 plus 1. If I fill in a -6, it's going to be 3 times -6 squared plus 6 times -6 plus 1. What's the only number that's remaining constant no matter what I fill in for x? The 1, because it's not affected by the x. We agree? So the constant term is the one that remains constant. Indirectly, it's the one without a variable. Now these are always asked in these weird ones where we have like an x and then we have a 1 over x squared or something. And the reason why that is because the x's up top are going to cancel off the x's on the bottom, and then we're going to end up with a term without an x, correct? So if I didn't have that x in the denominator on this one here, then they couldn't ask me for a constant term. They would never cancel off. And I would never have a term without an r. Okay, unless I had, if both of them have variables, that wouldn't work. So what do? This one, we're going to do the same as we always do. We don't know what k is, but we do know everything else. So we're going to fill in everything else in boxes for k. Okay? So we have 2x plus negative 1 over x squared to the 15. This is my x. This is my y. That's my n. And my k is going to be a box. So I'm going to go 15 C box. 2x to the 15 minus box. Just going to run into the other green, so I'm going to do that. Minus 1 over x squared to the box. Does everyone have that written somewhere? I'm just going to go to a bigger space so you can see. So I need 2x to a box. And you don't need to write this. I'm just showing you in a bigger spot so you can see what I'm doing. So once I figure out the boxes, then I can go back there and fill them back in, correct? But I need to figure out what the heck I need. I need something that when I fill in this number, oops, this needs to have, how many terms was there? 8? 10? I don't remember. 15? 15 minus box. So when I fill in something for that box, it's going to make those x's be the same power, like x to the 3 on the top and x to the 3 on the bottom. Then they're going to cancel and they're gone and I have a constant. We agree? Or x to the 6 and x to the 6, they're going to cancel and I have a constant. We agree? So we could use knowledge, which you're going to do eventually. If not, we're going to do educated guessing. So don't do this. Just pay attention. So say I pick a 1. They both have to be 1s, correct? Whatever's in one box has to be in another box. That's the stated thing. It's all k. So this is going to be 14, correct? So it's going to be x to the 14. This is going to be x to the 2. Do they cancel? No. Okay, now I'm going to try a 2. Eventually, after you do these, you're not going to try all these ones because you're going to realize they don't make sense, but that's okay. So this is going to be x to the 13, x to the 4. Do they cancel? No. So I'm going to try a 3. This is going to get really ugly looking. To 3. So it's going to be x to the 12, x to the 6. Did that work? No. Try a 4. X to the 11, x to the 8. We're getting closer, but still not good, right? Try a 5. X to the 10, x to the... Well, heck of a doozy. We got that. It's a 5, right? Done. Go up. Put 5s in your boxes. If you just randomly go 1, then 8, then 3, then 7, then 2, then 4, like you don't even know which ones you did. Just at least be productive and go in the same order, pattern up till it works out. So I'm going to go back up here, and it's 5. So I'm going to fill a 5 in for every box. What's 15C5? Yeah. Yep. And then this is 15 minus 5, which is actually 10. So what I have to remember to do is 2 to the 10 x to the 10. You have to remember to do that coefficient to the 10 as well, which is what everyone forgets. So I'm going to get 1,024 x to the 10. And then I have to remember to do this negative 1 to the 5. We agree? Negative 1 to the 5 is negative 1. And then x squared to the 5. Why do I multiply these exponents and not add them? One base, x, two exponents side by side, you multiply, correct? Had I had this, though, x to the 2 times x to the 5, two bases, two exponents, then I add, correct? But I have this, technically. When they're side-by-side buddies like this, you multiply them. When you have two bases, two exponents, you add. And we're always going to multiply in binomial theorem because you don't have two bases. Okay? You might add if we didn't get them to cancel, though. All right. So then I have x to the 10. Those cancel. And you multiply all your coefficients, and you get negative 3,072. Negative. So that is the constant term. The constant term is that. What's the term number that is the constant term? Term number what is the constant term? Yeah. 6, because once again we have our k equal to 5, and our k is 1 less than our term. Make sense? Yeah. So go put in the number. Then you go math. Arrow to the switch probability. Number 3. 5. There you go. Okay. So up until now, we've just been finding ways to get our k. We agree? They give us something, we decipher it, make k's, boxes. The last two are a little bit different in the fact that they give us what the term is. So we've always been finding the term, finding the term, finding the term. We've always known x, y, and n. We use k to find the term. We agree? The last two examples, they're giving us a term, and they're making us solve for a variable in the binomial. Not ridiculously hard, just a little bit different. Okay? So what we've always done in the past here is we've filled in our binomial, and in the end we have it equal to our term, correct? The answer? So what we're going to do is fill in everything we know about our binomial and set it equal to the answer that they gave us. That's it. Solve for A. All right, so let's try it out. One term in the expansion of x plus a to the 10 is this. So they gave us this is the answer. So no matter what, we're going to set it equal to that. They're still often not going to give us k, but because they gave us the answer, we can find the k. They want us to determine what a is. In order to have a variable that they're making us solve for in the binomial, they have to give us the answer. So in this case, they did. So let's fill in what we do know. We know x is x. We know y is a. We know n is 10. We have to find k. So we have 10c box. X to the 10 minus box. And then y is a to the box. Made a really small box on that one. Oops. Okay. Anyone have any idea how to figure out what that box might be? What that k value is? From the answer they gave us? Why? Because x is equal to 4 in our answer. So then this would have to be equal to 6 to get 4. You're right. So if the one box is 6, that means k is 6. So this is 6, this is 6, this is 6. So what's 10c6? You get 210 x to the 4, a to the 6 equals 3,281,250 x to the 4. And now we're literally back to solving from grade 10 and 11. I need to find out what a is. What can I do? Yeah. Yeah. Why can you cancel the x4 on the plus side? What are we, on both sides? What are we doing? What operation? They're multiplying. The x to the 4 is multiplying. But why, how can we cancel them off? What operation are we going to do to both sides to get it to go away? Yeah. And remember, do we want to skip steps? No, in the written response, if you skip more than one step, and they can't see that you're moving from this step to this step, and they can't see how you could just do that in your head easily, you aren't going to get full marks. So we don't want to skip steps at all. If they can't see from this step to this step how you could do that in your head, you're losing marks, which would really not be great. Okay? So we're going to get 210 A6 equals 3,281,250. Next operation, divide by 210. A to the 6 equals something. 15,625. Now, you guys have always had a squared, we square root, a cubed, you cube root, a6, you 6th root, which is absolutely fine. You can do that. But I want to show you how to do it with exponents, just because when we get to log and exponential, it makes it a little more complicated. So we have currently a6 equals 15,625. I want in the end a1 equals something. Ultimately, that's my goal. Correct? Every single time we're solving, it's a to the 1, b to the 1, x to the 1 equals something. That's our goal. So instead of saying take the 6th root of this, what could I raise this, what could I multiply this power by in order to get this to turn to a 1? That's what I want you to think. What could I multiply 6 to the 1 by? That when I multiply them, they would cancel out when I go to 1. So I have 6 over 1. What could I multiply it by as a fraction that would completely cancel off and be a 1? What fraction turns to a 1? 7 over 7, 8 over 8, 10 over 10, 12 over 12, 6 over 6 turns to a 1, correct? So I need to multiply this 6 over 1 by something that I can get 6 over 6 and it turns to a 1. What can I multiply it by? When you multiply fractions, you multiply across the top and across the bottom. We agree? Numerator times numerator, denominator times denominator. I need it to be 6 over 6. So I can multiply this by 1 over what? 6. If you multiply it by its reciprocal, you get 1, because it's going to end up being 6 over 6, correct? So I can raise this to the power of 1/6. Did you know from grade 10 that you guys used to do this in grade 10? You had that. You had a radical, and they made you turn it to a rational exponent, which means a fraction exponent in grade 10. So this was to a 1, correct? So I told you we could have just taken the 6th root of both sides. We agree? But this is also the same as saying x to the, you drop this underneath, 1/6. The 6th root of anything is x to the 1/6. So the square root of something is the same as saying x to the half, right? That number just comes underneath. So I could either take the 6th root of both sides, and that still works, or I could raise both sides to the 1/6. This cancels. And 15,625 to the power of 1/6 is. Put in your calculator. Now, if your exponent pops up, you can go 1 divided by 6 and you're fine. If your exponent does not pop up and look like an exponent, every time you have a fraction, what do you need to put it in? So your calculator knows it's a fraction. Yeah, brackets. The only way your calculator knows anything is a fraction is brackets. So you don't want to assume your calculator knows it's a fraction. You don't ever want to assume that because your calculator is going to do order of operations. So if there's no brackets, your calculator is going to do whatever multiplication division comes first. But if there's a bracket, it's going to do that first because it's brackets, right? BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. So the moment you put in brackets, it's going to do that first. It has to. Your calculator does order of operations. So what do you get? What's 15,625 to 1/6? 5? Wow, 5 has been the answer of the day. A equals 5. K values for 5. Now, if you want to do 6th root, you can. Do I have it on here? I don't have my calculator pop up. Okay, so what you can do if you want to do the 6th root, follow along with your calculator. You can go 6, math button again, and arrow down to the square root symbol that has an X in the index. So number 5. So what you're doing then is you're telling your calculator, hey, I'm putting the 6 in for that X, and then 15,625, sorry. And you should get the same answer. Yeah? Because they are doing the same thing. When you're taking the 6th root of something or you're raising something to the 1/6, that's the exact same math. Okay? I want you guys to try this one. It's even easier than the previous one because of one thing. They even tell you what term it is. So they're giving you K. So try this one out. Okay, this one we're going to do 13C. If it's the 11th term, I indirectly told you K equals 10. So 13C 10, A, X to the 13 minus 10, Y to the 10 equals the answer. But if I had not told you what term it was, you could still figure it out pretty quickly, just based on the variables in the term, the answer, right? Okay, there's one place where people will make an error, and I'm curious if you did it. So 13C10 is what? 286. And then this is where people error. 13 minus 10 is 3. That 3 has to go to the what? The A and the X. A lot of people forget to put it to the A. So you won't cube root your answer. Your answer will just be the non-cube rooted version or the non-version to the 3rd, right? And they'll be there. Okay, so we're going to have A cubed X cubed Y 10 equals 2,288. X cubed Y 10. And then I always want to show my work. I don't want to just cross them off. Just canceling them off is showing actually no math whatsoever. You just know they cancel, but do you actually know why they cancel? They cancel because of division. So you need to show your work. Always show your work. They cancel off because of division. So then we have 286 A cubed equals 2,288 divided by 286. A cubed equals what? 8. So if you forgot to cube the A, your answer is going to be 8, and it will be there, right? Common error. If not, you can cube root the 8 like this at this point and say A equals 2. Or I could have done the other way. A3 equals 8. This is 3 over 1. So I can raise it to the 3rd, both sides, the exponent, and I get A equals 2. Either way, exact same answer, because 8 to the 3rd, or the 3rd root of 8, is actually the same operation. One's just in radical form, one's just in fractional exponent. Right? Exact same operation being done. Okay.